Today we're going to consider the Monty Hall problem. Monty Hall was the game show host in the 70s, and he used to play this game with his contestants. He would show them three curtains. They'd be closed. They don't get to see what's behind them yet. And they were numbered 1, 2, and 3. And behind one of the curtains, he told his contestant, was a car, and behind the other two was a goat. It was always one really nice prize and two prizes that I guess nobody ever really accepted. So in essence, one curtain had a winning prize and the other two were empty. And so suppose the car was behind door 1 and a goat was behind the other two. If you picked one, Monty Hall would always show you one of the other curtains. He would show you what's behind one of the other curtains, but it was always a losing curtain. So he would show you either door 2 or 3, and you would see a goat. Now, for example, if you pick door number 2, that's the door you picked. So you pick 2. So Monty Hall can show you 1 or 3, but he never shows you the winning curtain. That is, he'll show you curtain number 3. And then he'd ask you, after he showed you one of their losing curtains that wasn't yours, he'd ask you, do you want to switch? So for example, if you pick door number 2, which has a goat, and he would then show you now you didn't see the goat yet, but he would show you what's behind door number 3, and it would be a goat. And then he would ask you, do you want to switch? And of course, if you switch from door 2, you would switch to 1. You're certainly not going to go and switch to door number 3. You saw it was a goat behind it. So if you switch from door number 2 to door number 1, in this scenario, you would have made the right move. You would have won the car. The question is, should you switch? Should you switch? That is, if you switch versus not switching, did you improve your chances of winning? Did you decrease your chances of winning? Or is their chance of winning still the same? Well, let's look at this carefully. If there are 3 curtains, 1, 2, and 3, and one of them is a winner and only one, if you don't switch, no switching, the probability that you win will be 1 out of 3. Because if you pick door number 1, there's a 1 in 3 chance that it's a winner. And Monty Hall, after you pick door number 1, he can tell you all kinds of things. He can show you a goat behind door number 3. He can show you a goat behind door number 2, or curtain number 2. It's still not going to affect that. The probability that you chose the winning curtain before you learned anything else is 1/3. And the probability that you lose is 2 out of 3. Let's just 2 losing curtains out of 3. So now, what happens if you switch? I claim if you have a winning curtain and you switch, you'll lose. And if you have a losing curtain and you switch, you'll win. Let's make sure that's correct. If 1's the winner, and you pick the winner, Monty's going to show you either door 2 or 3, and regardless of which one he shows you, if you switch, you're going to lose. So if you pick the winner and you switch, you lose. Now, what if you chose a losing curtain? What if you picked door number 2, a losing curtain. Well, Monty is going to show you the other losing curtain. Well, if you switch, you're going to switch to a winner. If I reverse this scenario, if you pick door number 3, Monty will, which is a loser, but you don't know that. Monty will show you a losing curtain, which in this case is door number 2, and if you switch, you win. If your initial pick is a losing curtain, if you switch, you win. So if you switch, the only way you win is if you pick the losing curtain, which has a probability of 2/3. The only way you lose if you switch. The only way you can lose is if you pick the winning curtain. And the probability you have picked the winning curtain from the beginning is 1/3. So if you don't switch, the probability that you win is 1/3. And if you do switch, the probability that you win has doubled. It is now 2/3. So the answer to the Monty Hall problem is switch. Now, let's do it more mathematically. Suppose you pick a curtain and no switch versus switch. So there's a lot of possibilities. Let's look at all of them. There's actually only 9. There's 3 cases. So let me be clear. You pick only the first number I write. You can pick door number 2. Or you can pick door number 3. And I'll show you in a moment why I'm writing them down 2 times. I don't even have to do that, but I will. Okay. In the first case, when you pick door number 1, either door number 1 is the winner, or door number 2 is the winning curtain, or door number 3 is the winning curtain. If you don't switch, in this first case, let's number them. 1, 2, 3, 4, 5, 6, 7, 8, and 9. In the first case, if you don't switch, you win. But if you do switch, winners become losers. In the second case, you pick door number 2, which is a loser. In the third case, sorry. You pick door number 1. In case 3, you pick door number 1, but door number 2 is a winner, so that's where you lost. And in the third case, you pick door number 1, for door number 3 is a winner, so you lost. In case 4, 5, and 6, you're picking door number 2. Either 2's the winner, or 1 is the winner, or 3 is the winner. In case 4, you pick the winner. You pick 2. In case number 5, you pick door number 2, for door number 1 is the winner. So you lost. In case number 3, you didn't pick, in case number 6, you didn't pick the winner. The winner is 3, but you picked 2. So you lost. And in number 7, 8, and 9, you keep picking door number 3 or curtain number 3. And either 3 is the winner, so you win because that's what you picked, or 1's the winner, so you lose because you pick number 3, or door number 2's a winner, so you lose. Now what happens is if you do switch, if when you didn't switch, if you won, then you lose. And if you did lose before you switch, when you switch now, you win. So W becomes L, and these two L's become W's, and this becomes an L, and these two L's become W's. Okay, so let's look at this a little bit more clearly. What's the probability that you win given that you did not switch? Well, there's 9 outcomes. We counted them. And you won 1 time, 2 times, 3 times. So you would win if you don't switch 3 out of 9 times, which is 1/3. But what if you do switch? The probability that you win if you do switch. Well, you do switch. 1, 2, 3, 4, 5, 6. Twice as many times. You'd win 6 out of 9 times, which is 2/3. So if you don't switch, if you're up here and you don't switch, the probability that you win is 2/3. And if you do switch, the probability that you win is 2/3. So you double your chances by switching. Okay, you double your chances by switching. If you don't switch, the probability that you win is 1/3. If you do switch, the probability that you win is 2/3. Okay. Now, let's just look at this slightly different because some of you still may not believe this. Now, notice that not considering the door you picked, Monty Hall opened up all doors but one. Okay? Or if you want to say there's 2 doors that remain, well actually 2 doors remain closed. The door that you picked and one other. Okay, that is he opened up all doors except the door you picked and one other, and he showed you the goat. Well, let's up the number of doors. Suppose there are 1,000 doors, an awful lot of doors. There's 1,000 doors. Now, and say for argument's sake, you pick door number 1. The probability that you win is 1 out of 1,000. And this is no switching. This is no switching. Okay, you don't switch. Now, let's look at this again. Door number 1, door number 2, ... Eventually door number 39, and then door number 40, all the way up to door number 1,000. Now, you pick door number 1, okay? Monty shows it's not in door 2, it's not in door 3, it's not in door 4, all the way up to it's not in door 39, it's not in door 40, it's not in door 41, it's not in door 42, or 972, all the way up to 1,000. So there's 2 doors that are closed. Door number 1, the one you picked, and door number 39. It's not now Monty Hall knew which doors to pick that had the goats, and we crossed them all out. Well, the ones that we crossed out all have goats in it. We showed you the goats. So between door 1 and 39, one has a goat, one has a car. Now, if you're gonna say that it's 50-50 now, Imagine you play this game 1,000 times. If it's 50-50, you're going to win 500 times. My question is this: how did you get so good at picking the winner? I mean, you picked the winning door before Monty Hall showed you which ones were definitely losers. Okay, he can always narrow it down to two because he knows which ones are losers. Okay, so it's not reasonable to assume that this door has the same chance of winning as that door. In fact, if you do switch, the probability of winning will be 999 out of 1,000. Basically, you get to pick all of these doors. You get, if you switch, here you just have one door, coincidentally door number 1. If you switch, in essence, you're getting all the other 999 doors. Okay, he's just nice enough to tell you, look, don't pick 2, don't pick 3, don't pick 4, don't pick 38, don't pick 40, don't pick 41, don't pick 42, and don't pick 1,000. Well, you only left one left out. That's the one that you should pick. It has, this is 999 times the probability of winning if you don't switch. That is 1 out of 1,000. You up your chances of winning by 999 times. If you don't switch and you play the game 1,000 times, you'll win once. If you do switch, on average, you'll win 999 times out of 1,000. Okay, it's insane not to switch. Yes, it'll be heartbreaking if you were the 1 in 1,000 who picked the right door and then you switched it. But let's face it, if you were asked to choose one door or to choose 999 doors, I think you would choose 999 doors. And then he'll be nice enough to show you, look, on those 999 you pick, it's not any of these. If it's going to be one of them, it's door number 39. Or it's your door. How likely is it your door? There's the Monty Hall problem. Switch. If you like mathematics like this, subscribe to my channel. Expect to see more math like this. Math that requires you to think a little bit. Please tell your friends about my YouTube channel, tell your teachers, and most of all, have a great day. Thank you.